Fluid Research Group brings together a large number of researchers from across the Faculty of Engineering who are involved in both computational and experimental research in fluid dynamics. Application areas are very diverse across both internal and external flow.
So there are a large number of application areas. They include things like aircraft, biologically inspired flows, ocean engineering, atmospheric modelling, as well as flows in and around buildings.
The research of the Fluids Group is aimed at improving our understanding and ability to model the physical world. That means that we can have a potential impact in a wide range of areas where fluids flow. So that can range from things like designing better aircraft, which could lead to reductions in cost and pollution. We could have impacts in things like better building design, which will reduce heating costs. Other areas could be predicting volcanic events and designing better heart valves, or reducing the environmental impact of wind turbines.
And even things where the way that we model the fluid flow can be taken into the way that traffic's modelled. So that actually changes the way that you might drive around the M25.
The main aim of all the research we're doing within the Fluids Group is to model real physical systems, be that numerically or be that experimentally. So if we're thinking about mathematical modelling, I guess the main challenge is that to model a real fluid flow is numerically expensive. And so we're always trying to focus our research on how do we reduce those costs to produce something that's actually more usable for in industrial applications. For experimental testing, the challenge is more if you're carrying out an experiment in a lab, how do you be sure that the data you're producing is going to reproduce something in the real world that you're trying to model? And in both these fields, there's an overarching challenge of you're going to generate huge amounts of data, which can become overwhelming and difficult to understand. And so one of the other research areas is to think about methods to process that data in such a way you can extract meaningful information in a short space of time.
For me, the most interesting aspects of my research are always whatever we're doing at the moment, and I think there's a tendency, certainly within researchers, rather than the subject to be interesting, that in fact they are just interested people. So I find that just about all that I do is interesting. So it's always an exciting thing to work on new things, and I think that is what is interesting, is the new. It's more of an applied maths for me. It's more of an applied maths subject, and I look at any problem in that way. So I'm always trying to turn it from the real world into a mathematical problem. Then once I get to that, that's where I think you become a crossword solver, where you're just trying to solve a smaller problem, and then you take that solution and you turn it back into the real world again. That's what we do. So the Fluids Research Group does a lot of research with a diverse range of